So welcome everyone. I think it's time to start. So Stack Overflow. Who doesn't use Stack Overflow? Oh, we have two people. Where do you get all the help? I would like to talk to you later. So I'll be talking about exploring Stack Overflow data. And first, little disclaimer, I have nothing to do with Stack Overflow. I don't work for them. I'm in no way related to Stack Overflow. I am actually related to University of Cambridge. And talking about exploring Cambridge would be really nice because it's a really beautiful place. Very nice, but yeah, I work here, so let's go back to Stack Overflow. I actually work in genomics, and I work with biomedical data, and they are incredibly complex every time. So why I work with data all the time, I like to relax by playing with data that I can actually understand, and that's not just about genes and proteins that I need biologists to help me interpret. So I decided to play with Stack Overflow data. And what actual data are there? Well, Stack Overflow has quite a nice API that you can use. You can just query it directly, and you can, for example, build a bot that will send you every new question with a specific tag if you want to build up your reputation. But luckily, I don't have to go through this and download everything all the time. Stack Overflow actually publishes a data dump every 3 months. And it's the entire data dump of the whole Stack Overflow, which is really nice, because for me, as a data scientist, I can just download this and play with that. So that's what I did. I downloaded all the data, and this is what it is. It's basically several very big XML files. And the biggest one is the one with posts and with post history. You can see that it's 41 gigabytes and 67 gigabytes. And altogether, this data set is 135 gigabytes of data, which is, it's not huge. Well, who think it's big data? Well, it doesn't fit into memory on my laptop. It would fit into memory on my work machine at work. So I don't think it's big data. It still fits into the memory. And it's actually possible to analyze most of it even on a laptop. So that's quite good. But it's still huge XML files, so that was a major pain. So now I have the data. And the next thing is, what do I do with them? And I get this all the time, even at work, where my colleagues come and say, OK, here you have a hard drive with 2 terabytes of data. I'm like, well, what do I do with it? Do you have any questions that you want to know about the data? And they're like, well, won't the data tell us? And the thing to understand is, when you are dealing with data, you need to have specific questions. Otherwise, you will never come up with good answers or good insights. You need to start with questions. So the first thing, even if you are just collaborating with data scientists, don't just give them data. Have some specific questions that can be answered. And you can also relate this to a scientific method by saying, OK, have some falsifiable questions that you can say yes or no, and you have a direct answer. So I will try to do something like this with Stack Overflow, but it will be mostly explorative. So what can we get from Stack Overflow? This is actually the first ever question on Stack Overflow. It's in 2008, so it's 8 years ago. And it's asking, when setting a form's opacity, should I use decimal or double? So not a very complicated question. And I think it has a very high reputation because it's the first question. I looked at the comments in this question, and I'm like, wow, this is the first question on Stack Overflow. And the main thing is you can get tags. All the questions in Stack Overflow are tagged with the topic. So this topic has the tags C#, WinForms, type conversion, decimal, and opacity. And this is amazing if you are dealing with data, because suddenly you have labeled data. You know topics of each question. So we can play with that a little. And actually, the tag data set, well, I had to go through all the posts and look at all the tags individually and extract them. And the first question you might ask is, so what is the most common tag on Stack Overflow? But Yeah, that's not a very interesting question because you can get it from JavaScript, from Stack Overflow directly. So the most common is JavaScript. Second one is Java. Third one is C#, and the fourth one is PHP. So that's not very exciting news. But yeah, here you can also see. Yeah, it's good that the screen is big. You can see that there are information like JavaScript, 992 asked today, 5,847 asked this week. So that's good. We know when people ask those questions with those tags. So I decided to look at when do people actually ask questions. And you can use this kind of information, for example, if you just want to build up your reputation, then you can check Stack Overflow in specific times. So the first question is when. And because I'm using F#, I'll be showing you some really nice features of F# for working with data. But first, I actually extracted the data into something that's easier to work with. And I have a huge CSV file. It's more than 1 GB big. And it's basically just the time of day, the day of week, and the tag. So the first question in 2008 had a tag C#, WinForms, etc. And it's a very, very long file. I can have a look at number of items in there. And it's still counting. OK, so it's around 33 million items. So it's relatively big, and the size is actually, I have it here, 1.1 GB. So I'll go into F#, and I will be showing you type providers, which is a way how to access data from your editor. And I'll be using something called Csv Type Provider. So I will first create a type for the file I'll be exploring, and let's say tag time. And I will open a CSV provider and give it the address of the file. Now it checked the file, and it's OK. And now I can just load it basically behind the scenes into my type checker. Let's say tt tag time get sample. So what it did right now is that it looked at the file and constructed types based on contents of the file. And now I have it in my editor, and I can do tt dot. I should be looking at rows. And I can just, because I'm a functional programmer, I do c.map fun row. And now I do row dot. And now I know what the columns in the file are. Now I see that the first one is day of week, the second one is tag, and the third one is time. And I also know that, for example, the tag is a string, and the time is system.datetime, which is amazing because if you've noticed, I haven't run anything. It just all runs basically in the type checker in the background. So now I have access to the 1 GB file, and I can just dynamically change things and explore it, etc. And well, I won't be running it because it would take actually quite a lot of time to load everything into the memory because it's still 1 GB. So I think that's pretty exciting because I don't actually have to even load the file. I can just write the program. It's correct. Otherwise, it would tell me, my type checker would tell me that it's wrong. And then run it, and I know it will be correct because it knows the types in the file. So I ran the code, and I looked at various different tags. So this is, for example, F#, and how many questions with a specific tag are asked during different days of week. And yeah, you can see a dip over the weekend because people are at home. And then I looked at C#, and it's very similar. But if you look at it closely, you can see that it changes a little because there are more people asking questions about F# on weekends than they are asking about C#. You can see that the ratio changes a little. So then I got an idea. Well, why do people ask questions on Stack Overflow over the weekend? Well, basically because they are working on their side projects. Right? Like, who would ask a question about something like enterprisey over the weekend? Well, maybe some poor souls that are at work. And quite a lot of us have side projects. This is actually my friend Chris, who's over there. And he is working on a side project on a tourist trip in the mountains. Because we all try to find time whenever we can. So this is Chris working on his side project. And I think I'll be showing that side project later as well. So that's quite a good idea, right? If people ask questions over the weekend, that means it's just a hobby or a side project. If they are asking during the week, that means it's enterprise or their work, corporate stuff. So let's have a look at it. And here I have some data. And what I actually did, I just basically parsed my data set with tags and time, and basically just collected it by day of the week. And another nice thing in F# is that, for example, I tried to, when I was plotting it, I wanted to sort the days of the week by their number. Like Monday is first, Tuesday is second, etc. So it's not alphabetic ordering. So I have this function that basically just looks at tags, counts them by Monday, Tuesday, etc. And then I'm sorting it. So I'm basically just doing pattern matching over the day. And the day is a string, as you can see, should be. It doesn't want to collaborate. But the thing is, it knows that it's a day, so it can have, that it's a string, so it can have any possible value for a string. And here I'm doing pattern matching only against Monday, Tuesday, etc. So I get a little red squiggle under day, and there is a warning that I have incomplete pattern matches, because I am not matching any string, which is very helpful. So if there was any string that I wouldn't be matching right now, it would crash. So that's a very important thing to know from the compiler. But I computed the ratio of how people actually ask questions over the weekend and how they are asking them over normal working days. And now I can have a look. So let's have. So what's the weekend ratio for F#? I need this one. No. I'm calling things in the wrong way. So on weekends, on average, people ask 65% as many questions on F# as they do during the weekday. So that means there are some people using F# for their hobby projects. How does it look for C#? For C#, actually, people ask only 42% as many questions on weekends as they ask during the weekday. So less people use C# for hobby projects. Let's say how it looks for JavaScript. And for JavaScript, it's 51%. So 50% less people ask questions over the weekends. And then I was thinking, so what are like the new exciting things? For example, Elm. That seems to be very popular nowadays. And actually, did I not load it? Well, I will get to this later. So I decided to have a look. So what are the most weekend things and what are the most like weekday things? So I'm just load the file and sort it. I did something wrong. Yeah, it's okay. Thank you. So the most weekend things are actually. Yeah, I need to print it first. So the first most weekend thing is Minecraft. That does make sense, right? And it's like 110% of people ask questions on weekends compared to weekdays. That means more people do Minecraft over weekends. That kind of makes sense, right? That's good. The second one is LWJGL, which is actually a lightweight Java game library. So it also makes sense. And then we have SFML, which is like sort of library to like connect to your hardware in your computer. So that's also like people use it for writing games. And then we have D and Pygame. So these are the most hobby things that people actually do. And what are the most enterprisey things? I can do the same. I just reverse the sequence. So the most enterprisey thing is SSRS, which is SQL Server Resource Services. Like, no one does that in their free time. So, and DocuSign API. Yeah, that's not the thing you would do in your free time, usually. And Exapta, I had to look it up, and it's like, even if you look at the Wikipedia page, the first thing, it's enterprise. So, it's kind of good. It tells me, the results kind of make sense. So then I decided to just plot some random functional languages. So the first one is F#, and the percentage is 65%. Then Scala is quite similar. So sometimes people say that F# is only used for like hobby projects and side projects, but actually a similar ratio of people like, ask F# questions over weekends as they ask Scala questions. So that either means that people are using both of these for hobby projects, or it means that also that people just love these languages, so they play with them in their free time as well. This is Clojure. Even more people ask Clojure questions over weekends. And Haskell, that seems to be like everyone's side project. So it's almost like 90% of people ask compared to weekday. And yeah, here is Elm, and it's over 100%. So Elm is, at this moment, mostly a side project language. So this is quite useful information. If you want to learn some language, you want to see if people use it in their free time or not. And then I was looking up some various like random things, and one thing that jumped out of the data was continuous integration. Who uses continuous integration here? Yeah, like a lot of people. So the two main frameworks for this are Jenkins and Travis. And Travis is the one that's used mostly, like a lot in weekends. So its number of questions over weekend is 60% of the number of questions over weekdays. But for Jenkins, it's only 20%, which means that people use Travis for their side projects and open source, and Jenkins just for their corporate stuff. They don't ask Jenkins questions over weekends. And this is quite an interesting insight because, well, it kind of makes sense because Travis is hosted by Travis, so you don't actually have to like set up your own server and maintain it. Whereas for Jenkins, you have to maintain the build server and everything. So the insight from this is like think about like who you are building your products for. Because if you want people to love your products and use them even in their free time, then just make it as easy as possible. And I'm not sure if it's helping Travis get into industry as much as Jenkins, but it definitely makes people more familiar with it because people use it in their free time. So that's my first thing with Stack Overflow data. Now, what other questions can we ask? Well, this is profile of Jeff Atwood. And another interesting piece of information is the address. Because actually, Stack Overflow offers you an option to put in your address. So the next question I decided to ask is where? Where do actually people live? Where do they ask Stack Overflow questions? And overall, in the dump I downloaded, there were over 5 million users, and almost 800,000 of them filled in their location. That's quite a lot. That's more than 10%. So how does it look? Like, if someone asks you for an address and it's just some website, do you put in your true address? Well, some people put in things like $home, which is, yeah, home. But actually, 83% of the people put in at least their state. And the state corresponded to like a normal name of the state. I just did a quick matching with like state names compared to people's locations. So 83% of people put in their state names. But some people put in their, like, some people, yeah, sometimes it looks like this, like, unfortunately, Germany. But yeah, it's Germany. For other people, like, I think it was mainly people from the US or India where they put in even their office numbers. I'm not sure if they want people to just knock on their door and answer their questions directly, or knock on their door and say, oh, thank you, I loved your answer. Well, some people put in their full address, but I don't think anyone is going to knock on their door. So people are asking Stack Overflow questions even in Antarctica. And this place actually looks like this. Yeah, the base is right there. So maybe a penguin will come and knock on the door. So I did quick pattern matching with just states, and then I decided, well, so how do I match the rest of the people? Because most of these locations were like truly like normal locations, but some people had just their like city name or American country name, etc. So I decided, well, there are several different services that offer geolocation for you. So I decided to use the Bing geolocation because they have the largest limits on number of requests that you can do for free. You can do, I think, for educational purposes and non-profit purposes, like 120,000. And I had about 30,000 of unknown locations. So I had to play with it a bit to get it to work properly. So, and did I mention type providers? Well, I was showing you the Csv Type Provider, and the second very useful one is JSON Type Provider. And you can see that here, what I'm doing is I'm just basically creating a JSON provider, and I'm giving it a sample API request. And that's all, because right now, this is just the request. This is my secret Bing key. I'm not showing you. And now, when I have a URL, I can just do let result equal Bing load, and I can just load the URL. And if I do dot again, now I get the result in the JSON. And again, I get all the typed results in my editor, in my type system as well. So I think all the values were in resource sets. And now I do r dot, and now, yeah, it's resources again. And now I do array.map. Now I'm going through individual resources. I do r dot, and I have the address, I have confidence, I have geocoding, so GPS coordinates, I have name, etc. So that's amazing. I didn't have to do anything, and I didn't have to write any parsers, anything. All you see here is that just I gave it just a sample, and I used the JSON Type Provider, which does all the rest of the work. And you see that I'm using a different editor right now. I'm using VS Code, and I think Chris, my friend over there, was coding this when he was sitting on the meadow during his free time. So he does the F# tooling for this editor. So I actually have the code here, so that I don't have to write everything. So this is just a little like, processing around the thing I was showing you before. So the main thing here is, again, I'm just basically here creating a URL request. I'm loading it into my JSON Type Provider, and then I'm just parsing the result and getting a name, an address, a country, and its GPS coordinates. So let's test it. It should hopefully work if the internet works for me. So where is Krakow? And Krakow is in Poland. Yes. So what can we locate next? Well, I was putting in random things. So because people on Stack Overflow were actually putting in random things. So let's say galaxy. We are in a galaxy, right? Enter. And galaxy is a town in Thailand. Good to know. And then one of the users actually put in the universe. So what will it tell us? Well, is there something called universe? Yeah, thank you. Universe. Yeah, the universe. It didn't give me any country, but it gave me GPS coordinates. So I decided, well, so where is the universe? Let's put it. Let's go to Google. Don't tell Bing. So let's search the GPS coordinates. Where is it? Where is the universe? Wow. It's kind of in the middle of the ocean somewhere. And then I realized, okay, the universe is in Dubai. So I actually started Googling that, and I found that actually in Dubai there was this development project where they built, where they were planning to build the universe islands. So the map on there, it's like a map of the Earth. So if you put in the Earth, one of the results is actually this location as well. And the universe is the thing underneath, and it's supposed to be the Milky Way, etc. So yeah, I think these things on the sides are supposed to be palms, but I think they are Death Stars. They never built the universe. And so that was a bit disappointing. But now I got fairly reliable geolocation for all the locations. So I could basically locate most of the users. And so where are they? Then I decided, well, we can also have a look, if you go to a country, what's the probability that you will meet someone that codes in your language? So for me, that might be, so if I go somewhere, where is the highest density of F# programmers? That's useful to know, right? Because if you just look at the number of posts on Stack Overflow, it will be like the US, China, etc. Because that's where most people live. So it doesn't tell you actually that much. So I came up with very mathematical formulation to basically compute the number of programmers per million inhabitants. ppm. This is actually not a complete bullshit because I use ppm in form of parts per million for some genomic computations. So this will be the number of programmers per million inhabitants in a country. So let's have a look at that. I'll go back here. Yeah, so how do I actually get the number of inhabitants? Well, did I mention type providers? There is something called the HTML type provider. So I think by now you can probably guess what it does. And what this does is actually it goes on Wikipedia. Well, I decided to go on Wikipedia and get information on population from there. So here you can see that I'm just, again, creating a type called population, which is an HTML type provider. And I'm giving it a URL. Don't go on that website and change it right now. I'm using a stable URL for one version. So you won't mess up my demo. So now I can do, again, the same thing I was doing before. I'll just load the document. Now type dot. Yeah, tables. Yeah. So now I have the tables that are on the website, and I can do dot. Sometimes it takes some time to load everything. Yeah, so now it actually went on Wikipedia and loaded everything, and I know that there is a table called countries and dependencies by population. So that's exactly what I want. And now I can work with it, and I can, again, go through it and do I need rows. Sometimes this takes some time to actually put up. So sometimes it works better, sometimes it works worse. It should work in Visual Studio as well. Yeah. Demos, they never work properly. Yeah. Row dot. Yes, I got it. So now I know that in every row in the table is the percent of world population, the name of the country, the date when they measured it, the population, which is a decimal. So I won't make any mistakes by I don't know, adding a string or something. The rank, like if it's the first, second, etc., and the source of the information. So, and I didn't have to look at the Wikipedia page at all, which is great. And if the internet was working a bit better, it would be even faster. Or maybe it would work better in VS Code. Right, Chris? So I did that, actually. And I wanted to show this thing first. OK. So this is my whole code that I put together, which is a bit more involved because I had to match names of the countries that I got from Stack Overflow with names of the countries that are on Wikipedia, because sometimes they use slightly different names. I think, for example, Brunei is officially something like the heavenly realm of peace, which is a great name for a country. So in the end, just let's have a look how many C# programmers are in the world. So this is how many people actually ask questions about C# on Stack Overflow. And you can see that most of them are coming from the US and some from India, etc. So that's not that interesting because the US has many programmers, India has many programmers. So it doesn't tell us that much. So I decided to basically compute the relative counts with respect to the population in programmers per million. And then I actually had to also get rid of outliers because they were sort of messing up the scales. So C# programmers, actually the highest density of C# programmers, based on my approximate method, is in Iceland. On average, there are over 2,000 C# programmers per million inhabitants. That's a lot, right? So how many are there in Poland? On average, almost 300 C-sharpers per million of people that are active on Stack Overflow. And then I thought, well, is it actually giving me anything reasonable? Well, let's check for something where I know roughly how it should look. So I decided on Erlang, because Erlang came from Sweden, so it should be mostly in Sweden. And it's true, there are 72 programmers per million inhabitants in Sweden in Erlang. That makes sense. And apparently China is using Erlang a lot. Who knew? So anyone wants to look at their favorite language? Python. China and Iceland as well. Interesting. And in Poland, there are roughly 200 Python programmers per million. So that's quite a lot. And what I was also doing is I was detecting some outliers. So it should also be telling me there are more than my statistical model would expect. Python programmers in China, Iceland, Dominican Republic, and Vatican City. Interesting, right? So I have a couple of plots. I'll just close everything. I have F# here as well. So F# is a lot in Scandinavia and in Denmark, which actually makes sense. They use F# a lot there. And I think we as F# community should expand to Iceland, because Iceland has a lot of C# programmers, but almost no F#ers. And as you saw, there was an outlier of Dominican Republic for Python. And that's almost for all languages, which is interesting. And I think the reason is that it's quite a good country for like the digital nomad thing. So quite a lot of programmers sit there on a beach and ask Stack Overflow questions. So if you want to just move somewhere nice and warm, I think Dominican Republic is the place to go. But one thing, this is very, very approximate, because have you seen the results of British elections and British referendum around Brexit? Like, everyone thought that Britain is going to stay in the EU because all the surveys before the referendum were saying, oh, it will be like 52% for staying. In the end, it was the opposite. And this is like a pattern in modern, basically, surveys before elections, because right now it's quite hard to get reasonable sized representative sample of the population. So I was just using like 72,000 programmers that were willing to share their address, which is one thing that biases the results. The second thing, it's very culture dependent if you actually even like answer questions on Stack Overflow. So that's also biasing it. And in some small countries, if there are like one company that's very active on Stack Overflow, then this will skew the results for the whole country. So they don't take it too seriously, but I think it's telling you at least where to go if you want to meet like-minded people. So next thing, now we have information about tags and information about users. So what can we do with that? Well, actually, this defines sort of like communities, because several users usually answer questions around several tags. They just don't answer everything. So tags define relations between users, and users define relations between tags. Because if the similar users are answering questions with the same tag, they make it immediately related. So if I take me and Chris over there as an example, this is how the data might look. And this basically is a great matrix that represents the data I have about users and tags. So the rows will be users and the columns will be tags. And I use F#, Chris uses F#. I don't use C#. I think in my life I wrote about 100 lines of C# when I was fixing a bug. But I think Chris wrote more in C# than I did. Everyone uses JavaScript. I use R, Chris doesn't use R, and none of us uses COBOL. So this is just an example of a matrix, how it might look. But if you look at all the data, actually, it's like, well, it's 44,000 tags and 5 million users. So that's a pretty big matrix. So I decided to make it a bit smaller. And I just looked at like very active users and very common tags. And I decided to basically visualize it, to see how it looks, how are the different communities related. And this implementation gave me 800 tags, which is already something I can visualize in a way, and 1,600 users that are on Stack Overflow probably all the time. So this is quite a nice sample, and it will tell me some relation between these technologies that are on Stack Overflow. And I decided to use my favorite data visualization technique at the moment, which is called T-SNE. And it's T-distributed stochastic neighborhood embedding. Who knows what that means? Well, it's a very complex name, but I will try to explain to you at least like how it works, the idea. And this is me yesterday in my hotel room, trying to demonstrate what it means to visualize a very, very high dimensional data, because I have so many data points. So this is a 2D plane. And it kind of makes sense, even in 3D, and the data on the plane are logically related. So if I want to see the distance between those 2 points, it's just this. If I want to see the distance between these 2 points, they are further away, so it's longer. And it still makes sense. But in very high dimensional space, the data might be concentrated on a sort of like a hyperspace, subspace, that might be, for example, curved like this. And then suddenly the distances in the space don't make so much sense, because like these 2 points are actually very close in this space, but not in the logic of the data, because in the logic of the data, they are very far away. So what the visualization method does, it actually basically just looks at local neighborhood of each point and tries to project it into 2D so that we can visualize a very high dimensional space in just 2 dimensions. And it's trying to preserve local similarities of things. And by the way, I just did the video to be able to tell my friends that, yes, I've been on the movie screen in a cinema. So I use R quite a lot. So this is how we would do it in R. You would just like take library and call it with the matrix. This is how you do it in F#. It's basically the same thing, and you use type providers. Did I mention type providers? I think I did. So you just call something called R provider, where you type R dot, and it calls R underneath and returns results into your F#, which is incredibly useful if you just don't want to export things into a file, then load it into a different language, then run it, export things, etc. So I use this quite a lot. And now you might be curious, so how did it turn up? So this is the result from R. Well, the best thing about R is that it was written by statisticians, and the worst thing about R is that it was written by statisticians. So this is how, if you make it a bit smaller, it's not very nice. Well, you can't really see much in there. So I just zoomed in into a couple of locations, and this is like the scripting bash cluster, and you can see there is Emacs and Vim right next to each other. So it knows that they are related in some way. And these are all like command line things. This is another cluster, and I'm not sure if you can see a lot of it, but there's like a polymorphisms, multi-threading, inheritance, garbage collection, properties, methods. I think this is like a group of people that are confused about object-oriented programming. So, and this is the data science cluster. So there is data frame, ggplot, which are R libraries, MATLAB, machine learning statistics, and graph and matrix here. So you can see that this simple visualization method could basically extract quite a lot of things from the data. It knows that matrices and vectors are very related. It knows that statistics and machine learning are very close, and that Vim and Emacs are both text editors. But yeah, you could see that R is not very good for visualization. So by that point, if you have the data, you want to move into something like a bit more proper, and that's the advantage of working with a normal language that's designed for programming. So I decided to create a JavaScript visualization, and you can do it in F# now with a project called Fable, which is F# with JavaScript compiler. And this is my visualization. It's work in progress. But at least in JavaScript, you can tell it to basically not overlap the labels, so you can actually read them. And if I just zoom in, for example, this is the Linux cluster. You can see there is Ubuntu, command line, terminal, etc. Make files, make Emacs, Debian, etc. So it's quite nice to just explore, and I hope I will make it a bit nicer later. But even though it's still quite messy, the labels don't overlap, so you can actually see what's there. This is the Jquery cluster. And what was interesting is that here is a huge cluster that just does Android programming. And here is a huge cluster that just does iOS. So now I got like how the tags actually are projected into 2D, but that doesn't tell me like the full picture about how the relations look. So I decided to look at actual communities and run some like clustering algorithms on the data. So we can basically treat the data as a network, where we have like tags as nodes, and how many people contribute to both tags on Stack Overflow as their links. So that gave me a network, and you can run a clustering algorithm that tries to optimize basically the number of links that are leading out of a community and that are in a community. And the assumption is that the links in a community are much denser than outside of the community. So I first looked at the communities that have no overlap at all. So there are two. One of them is iOS and R. So if someone is looking for a statistician to write an app for an iPhone, you have no chance. You'll have to hire two people. And the same thing for Django and middleware, which also kind of makes sense because these things are very, very different. And then I looked at the things that are most central in the network, and it also kind of makes sense because these are the arrays, strings, and performance. And these are things that everyone is basically involved with. Everyone does some arrays, strings, and performance optimization. And finally, the communities. Well, based on the algorithm that I used, some of them gave me like two very distinct clusters. One of them was like general programming, and the other one was web programming, mostly JavaScript. And with other algorithms, I got something like this. Can anyone guess what the cluster is? It's .NET. So, for those of you who are doing JavaScript, there is World out there that does other programming as well. And for those of you doing .NET, yes, there is a World outside as well. So we did look at tags and users and technologies that are on Stack Overflow. And the main thing are also like the questions and answers. But I actually did some analysis and found that Stack Overflow is actually really good in a way because if you answer a question, regardless of your current reputation, you get upvotes if your answer is accepted and if people like the question. And that's really good because that means if you help someone, it doesn't matter who you are, it's good. So on the technological side of things, I looked at, well, I showed you type providers in F#, so I hope even people who have never seen F# before see that it's quite useful for processing data and accessing various types of resources. And type providers bring them into your editor, so you don't have to go out. And I was also using R, because that's a great language for statistics. It's not a great language for presenting the data. And the other thing is on the data science part of things, yeah, the main thing is ask questions. If you are dealing with data, you need questions. And I showed you how we can basically recognize which projects are used for hobbies and which are used in the enterprise. That there are communities in programming, and I think the JavaScript programmers should reach out a bit more, and people from outside of JavaScript into JavaScript as well, because we should talk to each other. And please help each other on Stack Overflow. And move to Dominican Republic, if you are looking for a place to be. And that's all for me for now. Thank you. Do we have any questions? Yes. Well, the question was, the XML files were very big. How long did it take to process those data files? Well, I actually accessed them through type providers as well. And the CSV type provider is very nice because it doesn't load the entire file. The XML type provider works differently because XML can have almost any structure like underneath. It's not as regular as a CSV file. So it actually tries to load the entire file. And that's the reason why you usually don't do data science on a laptop. So I did it on a big computer that has like 150 gigabytes of RAM. So that was very easy to just deal with it that way. Otherwise, there are, of course, distributed frameworks. Like you can use either Embrace, which is a distributed framework for F# or .NET in general. There is also Möbius Spark, which is a Spark interface for .NET. But yeah, if you can just load it into memory, it's easier. Other questions? Well, if there are no questions, I will be at the conference today and tomorrow, so you can come and find me and we can discuss data science. Thank you.